So before we go any further, let's talk about the families of the periodic table. Now, so this is a colorful periodic table, just so that you could see the different colors on here. You can use yours, you can color in it if you want to, or you can just circle the parts. It doesn't matter. You can put the notes right on your sheet if you want to as well. On this, we've got the different rows that are numbered and our different columns that are numbered. So we're going to talk about the rows, which are called the periods, and the columns, which are called the groups. And each group is also going to have a family name. So just like in your family, you have a family name and you have certain characteristics that you all share. The same thing with the elements. So our periods are our rows, and they go from left to right on the periodic table. And our columns are the groups, which have family names, and they go from number 1 to 18 on the periodic table. And those families have similar characteristics. So just like in your family, if everybody had blue eyes, same thing with the elements of the periodic table. They don't have eyes, but they do have similar characteristics. So we're going to go through each of these things. So our first little thing on our periodic table here is we have a separation here between our metals and our non-metals. Right? So everything on this side of this staircase is going to be a metal. And everything on the right side of this staircase are going to be non-metals. So everything along here are non-metals, and everything over on this side are considered to be metals. So even though aluminum's over on this side, it's underneath the staircase, so it's considered to be a metal. Our first little division on the periodic table is little hydrogen on its own here. So hydrogen is kind of a little misplaced element. It's not a metal, but we've got it on the metal side of the periodic table because in chemical reactions it can act as a metal or it can act as a non-metal. It definitely is not a solid metal though. So this is sometimes it's called group of 1, or it's just called hydrogen. So what are some of the characteristics? Well, here, if you've seen a hydrogen balloon being blown up, you know it's very, very reactive. But it doesn't match the properties of any other group, so it just stands on its own. So that's, we just said hydrogen on its own. It's placed above group 1, but it's not actually part of that group. So keep that in mind. Even though it's on top of group 1, it's got nothing to do with the rest of what's in group 1. It's very reactive. It's colorless. It doesn't have a smell to it, so it's odorless. And at room temperature, it's going to be a gas. And it is very, very reactive, right? We've got that here. It will explode. And in the outside of its electron shells, well, it's only got one valence shell, and in that one valence shell, it has one valence electron. All right, let's look at the next little group. So this group here that goes from lithium down to francium, these guys are known as the alkali metals. So alkali metals, these guys are all similar in characteristics. So here's an example of an alkali metal. This is sodium. All these guys are shiny, they're silvery, they can actually be cut with a knife, which is kind of crazy when you're thinking about a metal, that you can literally cut some of them with a butter knife. These guys are extremely reactive. They're so reactive you can't even find them on their own in nature. They can't exist in nature on their own because they just react. So if you were to find a clump of sodium on its own, it would have been made in a lab. So it's never found in nature in the pure form. They're silver colored, they are shiny, and they have a very low density. These guys actually will float on top of water, which when you're in school, sometimes we show you a demonstration of that. They are soft, like I said, you can just cut them with a knife, and they have one valence electron. They only have one electron in that outer energy level. Our next guys, right next to them, is going to be our second group, our group 2, and these guys are going to be called the alkaline earth metals. So group 2 is known as the alkaline earth metals. Now these guys are slightly less reactive than the alkali metals, so you can find some of these kicking around on their own. You can find a chunk of magnesium. They're silver colored as well. They're more dense than alkali metals, so they don't cut quite as easily as the alkali metals do. These guys have 2 valence electrons in their outer energy levels. So here's an example of magnesium. It's kind of all shined up here, but this is what magnesium would basically look like. Now our next group here are all these guys in here. We're not going to spend a whole lot of time talking about the characteristics of these elements in here because they are busy. So all these ones in here are the transition metals, and they go from group 3 all the way over to group 12. So groups 3 to 12 are transition metals, so they have a range of reactivity. Some are very reactive, some are not reactive at all. They are shiny. They usually have different colors. This is where our gold, our silver, our copper all exist in here, and they have different colors to them. These guys conduct heat really well. They conduct electricity really well. They're also higher density, or higher density than the alkali metals and the alkaline earth metals. So these guys definitely will not float on water. And they have different numbers of valence electrons. So that's why we kind of just ignore them for now. When we get to doing some of the naming in grade 10, you'll see what we talk about, all these different valence electrons. So here's a chunk of pure silver, pure copper, and pure gold. So you can find these guys easily in nature on their own. These have all been nicely shined up to show you what they look like. Our next group here is going to be these guys. Now these guys in here are called the halogens. Halogen means salt former. So the group 17, the halogens, these guys are very reactive. So we're now on the non-metal side of the periodic table, and now we have very reactive nonmetals. So we had reactive metals and we have reactive nonmetals. And if you think about it, when we always talk about in chemistry, we always say opposites attract each other. So let's just imagine you had a reactive metal and then you have a reactive nonmetal. Those two things could probably get together. And these guys range from gas to solid at room temperature. They are also colored. And these guys, remember group 17, there's the 7 there in the ones column. So these guys have 7 valence electrons. So you're probably familiar with some of the components of the halogens. This is chlorine gas, and chlorine gas has a mustardy kind of yellow color to it. And if you remember from history, or maybe you haven't taken it yet, this chlorine gas was used in World War I as mustard gas to kill soldiers. This one here is bromine. Now this is a liquid at room temperature. The chlorine is a gas at room temperature. Bromine is a liquid at room temperature. And it also has a color to it, an orangey kind of color to it. And then this is, sorry, I'll go back to this for a minute. Some people have pools where they use bromine instead of chlorine in their pools. So that's where you may have heard of bromine before. And then here's iodine. Iodine is a solid at room temperature. It's kind of got a purpley color to it. And when it turns into a gas, when it sublimates into a gas, it makes a purplish kind of gas. All right, and you may have heard of iodine because they use this as a disinfectant before operations. And sometimes people also have it at home in their first aid kit to clean out wounds. So our last group here are these guys here, all right, at the very, very end. This is our group 18, our noble gases. These are non-reactive. So these will not blow up, they will not go on fire, they will not react with other things at all. They are non-reactive. They are gases at room temperature. They have 8 valence electrons except for helium. I forgot to write that on here, but helium only has 2 electrons in its outer energy level because that's all it can take, and it only has 2 electrons. The rest of them have 8 valence electrons in their outer energy levels. So these are things like our helium, and you know you can have helium balloons at a birthday party. You don't have to worry about the balloons blowing up if, you know, the cake candles get too close to it. You've heard of neon lights, and you want to be able to have a gas that you can zip electricity through and for it to have a nice color to it without it going on fire. So neon, argon, krypton, xenon, these things all do not react, all these gases. Now, part of the reason they don't react is because that outer energy level is full of electrons. It's satisfied. It is full. All those electrons that are in there, that outer energy level, are paired up. Remember we said the unpaired ones are the ones that cause the problems. So for our noble gases, the outer energy level is full, that valence level is full with as many electrons as it can hold, and those electrons are all in pairs, so they're all calm, cool, and collected, and our noble gases do not react. So that's it for our periodic table. Talk to you later.